In this video, I'm going to go over AP Precalculus topic 3.6, which is sinusoidal function transformations. Okay, we're going to be taking sinusoidal functions, which includes sine and cosine, and manipulating them in different ways. This goes back directly to topic 1.12, where we talked about the transformation of functions. These same things are going to apply for sine and cosine. So I want to do a quick review of what we learned back in topic 112. First, we're going to look at additive transformations. So either we add to the y or we add to the x, and that's going to translate the graph. If we're adding directly to the y, that is a vertical translation. And if we're adding versus subtracting, my vertical translation is going to move our graph up 2 units. So for this graph, this -1 goes to 1, 2 goes to 4, and so on. So my whole graph moves up 2 units. If we're adding or subtracting directly from the x value, then it's a horizontal translation. Okay, whatever this sign is, the translation will be the opposite. So we'll say this has a horizontal translation of -2, or I like to say we're going left 2. So this point I'll get back here, this gets brought here, and so on. Okay, had that been a -2, then we would have shifted it to the right 2. Then we have our multiplicative transformations. We can either multiply directly to the y or we multiply directly to the x. For the y values, that's going to be a vertical dilation. Okay, the vertical dilation for this one is going to stretch the graph vertically by a factor of 2. So my y values are going to get doubled. So -1 is going to be at -2. 0 stays at 0. To this point here is going to get pulled up, and so on. So the graph for this one essentially gets taller because it gets stretched vertically. If it's on the inside, it is a horizontal dilation. Okay, and it's going to be by a factor of the reciprocal of whatever that value is. So here I'm going to have a horizontal dilation by factor 1/2. It's going to compress the graph horizontally towards the y-axis. Okay, so this point here, rather than being at 1, is going to be at 1/2. This one at 2 is going to be at 1. This one, instead of being at 4, is going to be at 2. This one, instead of being at 6, will be at 3. And this one, instead of being at 8, will be at 4. So my resulting graph is the same thing, but it's squished in by a factor of 1/2. So these transformations are going to work the same way when we deal with our trig functions. Okay. Before we get into applying those transformations, let's remind ourselves what sine and cosine look like. So I'm going to call these the parent functions for sine and cosine. Sine of 0 is 0. So when we start the sine curve, it starts at the midline, goes up, down, up, down. It has a cycle of 2 pi, and its start, now that's not a great word because we know this is an infinite curve and it's going to keep winding, but when it crosses the y-axis, before we apply any transformations, it starts at the midline and goes up. Now, if I do a negative, this is another type of transformation, but I want you to be aware that we can write a sine or a negative sign, which is simply going to reflect that graph above over the x-axis. Cosine, its start, again, bad use of the word, but I think it helps with the visualization, crosses at 1, then goes down to pi over 2, down to -1, and back up. So these 5 points we want to get really familiar with for our cosine graph. Negative cosine is going to start at that bottom, or the minimum value. Now we know from our previous lesson that, again, these curves go on forever, but this is going to be our basis for our transformations. Okay. So now we're going to apply these to our sine and cosine curves, and they're going to have slightly different names. Okay, we've already talked about these attributes. The amplitude is the distance from the midline to the maximum or the minimum. This is going to be our vertical dilation. Okay, where we're going to be taking the graph and either stretching it vertically or compressing it vertically, which is going to change our amplitude. The period is how long it takes to complete one cycle. Well, if I change that, then we have a horizontal dilation. Okay, if I apply a horizontal dilation, the period is going to get either shorter or longer, which is going to make the graph compress horizontally or expand horizontally. Okay. In our formula, f of x equals a sine bx and g of x equals a cosine bx, the same transformations we were talking about before are applied here. So my vertical dilation is when we multiply the outside by some value. So my amplitude is going to be the absolute value of whatever that is. Because a can be negative, and that will give us a reflection. But whatever that number is out front, that's our vertical dilation from the graph of sine, and that will be our new amplitude. Our period is going to come from the coefficient of x. This b will be a horizontal dilation by a factor of 1 over b. So if the period of sine and cosine is 2 pi, the period is going to be 2 pi divided by whatever that b value is. Okay, so given our equations here, we're going to identify the amplitude and the period. Amplitude's easy. It's always whatever our coefficient is. So our amplitude is going to be 3. Period is always 2 pi divided by the coefficient of theta. In this case, I could rewrite that as 1/2 theta if that makes more sense. But my coefficient is going to be 1/2. So 2 pi divided by 1/2 is 4 pi. Here, my amplitude is 4. It may be tempting to say -4, but amplitude is a distance. Our period is going to be 2 pi divided by our b, which is also 2 pi. So this graph is going to have a period of 1. Next, we're going to be writing an equation given some different information. So we're going to write an equation with an amplitude of 5 and a period of pi. So my a is going to be 5. And just off to the side, I'm going to make a note. My period is equal to 2 pi over b. If I multiply over b and divide over the p, the b value I'm trying to find is going to be 2 pi divided by the period. So my b is going to be 2 pi divided by my period of pi, which is 2. So in my equation for sine, we're going to have y equals, or f of x equals, or g of x. And they don't give us a variable, so you can use x, you can use theta. I'm going to say y equals 5 sine, and then in parentheses, 2 theta, or 2x. Okay, this one, my a is going to be 8. My b is going to be 2 pi divided by pi over 2, which would be the same thing as 2 pi times 2 over pi, or 4. So this one's equation is going to be y equals 8 sine 4 theta. Okay. Next, we're going to write the equation for each graph. So the first thing I want to do is identify my amplitude and my period from the graph. So my amplitude from 0 to 3 would be 3. My period, starting here, following to another max, is 2 pi over 3. Now this one, we have another piece of information that we need to get from the graph, and that's which trig function is going to best model this. Now in a little bit we'll have phase shifts, so we could use either sine or cosine. But if I'm starting at the maximum, crossing the y-axis, this is going to be a positive cosine graph. So my A is going to be 3. My B is going to be 2 pi divided by 2 pi over 3, which is going to be a 3 when I multiply by that reciprocal. So putting all this together, I'm going to use x this time. We have A cosine, again because of our starting location, 3x for our equation. Okay, here my amplitude needs to be a pi over 2's. Amplitude is going to 2 and negative 2, so my amplitude is 2. The period is 3 pi, and I'm starting at the midline, so it's going to be a sine, but sine goes up if it's positive sine, so this is going to be a negative sine. My B is going to be 2 pi divided by 3 pi, which is 2/3. Putting all this together, f of x is equal to a negative 2 sine 2/3 x. All right, we're going to add another element to our general equation. I'm going to add a plus d. We know that that's going to be a vertical translation. So what we call that for a sinusoidal function is a vertical shift. And the vertical shift is going to be d. That will affect our midline is going to be y equals d. Okay, so let's write another equation for this guy. Amplitude. Okay, my midline here is at 1. So my amplitude going from 1 to 3 or 1 to negative 1 is 2. My period is pi, which means my B is 2 pi over pi, or 2. Then I have a vertical shift of 1. So when I put this in my equation, oh, and which function? We're starting at the midline, going up, which means I'm going to call this will be a sine. Okay. So we're going to have a positive 2 sine 2x plus 1 for that vertical shift. Okay, so as we start to build elements, we can look at different problems like this where we've got a bunch of different graphs and we're trying to figure out which of these is the graph of 3 cosine x over 2 minus 2. Now, all of these have a vertical shift of negative 2. So that characteristic isn't going to distinguish itself. Next thing I'm going to look at is what function I'm using, cosine. Cosine is going to start at the maximum when we cross the x-axis. So A and C are out there. These would be sine curves. The next attribute is the difference between these two graphs is the period. So when I identify the period is 2 pi divided by 1/2, which is 4 pi. So the graph that has the correct elements is B for this one. Okay, next, the trig function k has a maximum at 0, 10. After this maximum, the next minimum occurs at pi 6. So I'm going to sketch myself a little picture. I'm a visual person. Okay, so I'm told I have a maximum at 0, 10 and a minimum at pi 6. Okay, I'm going to go ahead and extend my graph. to the next maximum, like so. So let's identify our attributes. The amplitude, let's go ahead and draw in our midline, which would occur at 8. Amplitude is going to be 2. My period is 2 pi. My vertical shift is 8. And if I'm starting at the maximum, we have a cosine. So if my period is 2 pi, my b is 2 pi over 2 pi, which is 1, which makes sense because cosine and sine have a period of 1. So my function f of x is going to be a positive 2 cosine 1x plus 8. The last element that we're going to add on is a phase shift. The phase shift is what we call the horizontal translation of a sinusoidal function. We can take our graphs and shift them, and that will be out of phase, is what we call that. So our general formula, all put together, is going to be a sine b times the quantity x plus c plus d. So our new piece here is the c. Our amplitude is still the absolute value of a. My period is still 2 pi divided by b, lowercase a. My vertical shift is still going to be d. My phase shift is going to be negative c. Just like with our regular transformations, whatever happens here, this is going to be opposite that. Okay, so which of the following could be graphs of 3 cosine x minus pi over 2? So they all have an amplitude of pi, or amplitude of 3. What we're looking for is a cosine that has been shifted to the right pi over 3, or pi over 2. So we're looking for the maximum to occur at pi over 2, because if we have a cosine and we shift it, it's going to have a maximum at pi over 2. And the only one that has that is this one. Now be careful, because you might be tempted to say this one, because that's a minus and that's minus, but remember it's always going to be opposite. In my last example here, I have 4 different equations that could match this graph. Now I want to make a note before I do that. If I didn't have this, you'd probably say, oh, it's a cosine with a vertical shift down 1 and it's got a period of pi. But here, these all have phase shifts to them. So we need to match the graph to one of these. Okay. To that point, there's an infinite number of equations that are going to match each of these curves, because I could write this with a positive cosine, I could write it with a negative cosine, I could write it as a sine, I could write it as a negative sine, just with different phase shifts. So if I'm looking here, I have the same amplitude, the same vertical shift on all of them, the same period on all of them. The difference is the function and the phase shift. So what I'm going to do is I'm going to look at if I had a sine with a phase shift of negative pi over 4, sine with a phase shift of negative pi over 4 would start at the midline, back negative pi over 4, which this one seems to work. Let's run through the others just to confirm. A negative cosine would start at the bottom, at the minimum, and move over pi over, this one goes to the right, right pi over 4, which this one does not. Here, I'd have a positive cosine moved to the left pi over 2, so that one's not right. This one is a negative sine, which would start at the midline and go left pi over 4, which could also be an option. Sorry, that didn't make sense. So if I had a shift, it would go to negative. So it would cross here, but if it was a negative sign, it would go down first instead of up. So my correct option is A, where we have a positive sine curve that's been moved to the left pi over 4 units. I hope you found this helpful. Thank you for watching.